Hello class, my name is Wallace, and I am in the United States Navy. I am a Master at Arms, which is military police, and I am proud of what I do every day. I am in Intro to Physics, and let's start learning. In the beginning of this lab, we will find the photoelectric effect and the emission of electrons from a surface when illuminated with light of a certain frequency. To start this lab, we will make our intensity to 50%. And as you can see, the electrons are moving. And now we will move our wave frequency up till the electrons stop moving. And as you can see, it stops moving at 541. We will need to find frequency, which we have our wavelength is 541 equals 3 times 10 to the 8th. Once we have our numbers plugged in, we will divide by 541 and it will give us an answer of 5.55 times 10 to the 14th Hz. Now we have to find energy, which H is 6.6 times 10 to the negative 34. Our frequency is 5.55 times 10 to the 14th, and that will give us 3.66 times 10 to the negative 19 joules. Now we want our energy in electrovolts EV, and 1 EV is 1.6 times 10 to the negative 19th joule. So we have our 3.66 times 10 to the negative 19, and we will divide by that 1.6 times 10 to the negative 19, and we will get an answer of 2.3. Once we have finished the first step for sodium, we will complete zinc, copper, platinum, and calcium all the same way. Once we have finished our first step, you will see that the chart is all filled out and we have all of our final answers for the first part. The minimum frequency of a photon that can eject any electron from the surface is called the threshold. The threshold of sodium is 5.6 times 10 to the 14th power Hz. The threshold of zinc is 10.3 times 10 to the 14th Hz. The threshold of copper is 11.3 times 10 to the 14th Hz. The threshold of platinum is 15.2 times 10 to the 14th Hz. The threshold of calcium is 7.0 times 10 to the 14th Hc. The minimum amount of energy required for an electron to escape from a metal is called the work function and is given by the equation W equals H times F. As you can see, our final answers we get is sodium 3.66 times 10 to the negative 19th joules, and the work function of EV is 2.3, and for zinc, the work function in joules is 6.82 times 10 to the negative 19th joules, and for EV is 4.27. For copper is 7.47 times 10 to the negative 19th joules, and for its EV is 4.67. For platinum is 10 times 10 to the negative 19th joules, and for EV is 6.22, and for calcium is 4.62 times 10 to the negative 19th joules, and for its EV is 2.89. As you can see, that the relationship between the intensity of the incident light and the number of the ejected electrons is that the intensity increases while the amount of electrons come out. With the relationship between the intensity of the incident light and the energy of the ejected electrons, we can see that the energy of the incident photon must be higher than the work function in order for the electrons to be ejected. In conclusion, we were able to figure out the wavelength, frequency, energy of different metals in this lab.